Howdy folks, welcome back to Advent of Code 2024. Today we are going to be looking at day 11. Let's see what they have for us. The ancient civilization on Pluto. Okay, so now we're on Pluto. Exciting. There are some stones, normal stones, in a perfectly straight line, has a number on it. Every time you blink, the stones change. Okay. So the number changes, sometimes it splits in two. If you observe them for a while, you find the stones have a constant behavior. Okay, if the stone has a 0, it's replaced by a stone with 1. If a stone is engraved by a number as an even number of digits, not the number itself is even, but the digits are even. Replaced by 2 stones, left half are engraved on the new, the right half are engraved on the new right stone. Okay. Okay, so they don't keep extra leading zeros. Okay, so that just splits in half there. If none of the other rules apply, the stone is replaced by a new stone. The new stone's number, the old stone's number multiplied by 2024 is engraved on the new stone. Okay, so if you do have a stone with 0, it goes to 1, and then it goes to here, and then it splits. Okay, no matter how they change the order of preserved, they stay on the perfectly straight line. Okay, so if you have this arrangement, the first stone becomes 1, the second stone becomes 0, this one gets split, the fourth stone is split, and this one is multiplied because it's not an even number of digits. And this is still not an even number of digits. So at some point it just, yeah. Okay. Okay, so this is after 1 blink, after 2 blinks. What did this, okay, that one split with this one. Okay, that one split in half there. 7 multiplied, okay. Okay, after blinking 6 times, you would have 22 stones. After blinking 25 times, you have this many stones. How many stones will you have? Okay. Okay, interesting. So here's our sample. Let's pop that in there. Sample. All right. So basically, we have to split this into an array and then loop continues over and perform some operations on it. Doesn't seem that hard. Let's pull in our code. And that file equals, path.join. Oh, wow, that doesn't make any sense at all. Sample. And let's pull in our content. Okay, UTF-8. So now, presumably, this is always just, let's just look at our puzzle input. I think, yeah, okay, it's just a single string. So we're going to get this string and we're just going to split it. Nums. Split, let's split not by that. We're going to split by a space, and then we're actually going to map in order to convert these to integers. Like so. So now this should give us a list of numbers. Let's just take a look at that and make sure. Uh-oh, because, you know, you got to spell things correctly. If you spell things correctly, then they tend to work a lot better. Okay, so there we go. And now we have to loop, okay? So first of all, let's just take a look at, I'm using this rather than the for of because occasionally we want to split stones in 2, which means we need to know where those are. So we need the index. Okay. Now here's actually an interesting thing. There are some bugs you can run into. Or let's say I'm running through this and I split something and I append it, then the next time we run over that loop, it's actually going to run over that. The I is going to increment. We're going to run over the one we just added. So what I'd like to do here is actually new nums. We'll just create a new array, and as we go through our numbers, we'll just add new elements to that array, which actually means that we can use the for of, because I actually don't care about the index then. So yeah, we'll just create new arrays every time because that's just simpler. The array itself should technically be immutable for its run. This will take up a little bit more memory, but it should be okay because I don't think we're, like, even with 55,000 stones here, I don't think we we're not using that much memory, so we should be okay. Okay, so if number, well, let's actually do this. Let's convert it to is divisible by 2. So basically what this is doing is this is turning this into a string so we can get the count of digits, getting the length and then modulus by 2. If that is 0, it means that there's an even number of digits. Actually, is that the first rule? Oh no, the first, okay. The stone isn't greater than number 0. Okay, so we should do these rules in order because this says first applicable rule. So if num equals 0, wow, I'm having a really hard time typing here. All right, equals 0, then new nums gets 1. All right, based on that rule. Okay, so then the even number digits, we split it in half. Okay, so if it's there, then first num equals parse int, and then we actually need to take our, let's just do this then, because we might need to refer to this a couple times. We actually need to get str_num.substring of 0 to str_num.length divided by 2. And then the second one is going to be backend. It's going to be from here. I believe this is actually, we'll have to check this out. I think it might be exclusive, which means this might not work exactly correctly, but we'll see. And then no, we're just going to push them independently. Okay. Okay, so there we go. We should continue on these either because if for somehow this matches multiple rules, we don't want to deal with that. If none of the other rules apply, it multiplies. Okay. So then otherwise, new nums.push 2024. Okay. New nums, and I just want to see what comes out of this, out of our sample. Okay, cool. That kind of makes sense. Oh, and this does seem like that worked. I'm actually going to put a slightly bigger one in here just to make sure that that continues. Okay, so that does split properly, so that's perfect. All right, so now we've done that first level, and what we want to do now, let's make this a let, is we just want to loop over this. And just do this multiple times. Plus plus. And down here, yeah, let's keep the console log. That could be kind of useful. And then nums equals new nums. Perfect. And then just run over that. Okay, that split, that goes there, that goes there. That multiplies, that goes to 1. Split, multiplication, split, right, because it's 0. Okay, multiplication, this gets split, that gets split, that gets split. Keeps going, keeps going, keeps going, etc. All right, so now I'm actually going to turn this off, and let's just log. Just the end is going to be nums.length. 55312, which is what we expect. So let's try it with our input. Let's see what we get. Okay, 185894. See what they think about that. Okay, cool. So before we look at part 2, let's take a look at our algorithm here. So first of all, we're getting a list of numbers, single line, separated by spaces. So that's pretty simple to pull in from the file. We just split it and then map it to get integers. We have a specific operation here. Every time we get our numbers, we look at every number, and if it's 0, we push 1. Or replace it with 1. If it has an even number of digits, we split them, which is kind of the most complicated part of this algorithm. Otherwise, we multiply it by 2024. We're using new nums here and then setting it at the end so that we don't modify our existing array, which just makes it takes away a lot of possible edge cases that could have problems. And then we just perform that operation multiple times, as many times as we need, and there we go. Let's see what we get for here. Okay, part 2. How many stones do you have after blinking a total of 75 times? Well, that's not amazingly hard. We just put 75 in here, and hopefully this doesn't crash the computer. It's taking a while. You know what? Let me do this. Let's actually start length. Just just for some interest to see how fast it grows. Okay. Oh, you can see that's that grows quite quickly. We'll see. If this crashes, we might have to make the algorithm a little bit better, but we'll see how it goes. All right, so we can see the issue that I'm running into. After I hit 40, we basically get this real fun error, which I think is an out of memory error, kind of. It doesn't look like out of memory, and I actually tried to run node again with more memory, and it didn't work, and so I suspect that this means the array might actually be getting too large. Not totally sure. So what we can do for this instead, let's set this back, and let's go to part 2, because this is now an optimization problem, okay? Which is kind of fun. So we need to optimize this so that we are reducing the memory pressure on our system. And there's a couple ways to go about that. But the main thing that we want to do is we don't want to necessarily be holding a ton of data in this array at this point. Now, what's cool about this is that the way this problem is structured, we don't actually have to. The stones themselves don't actually care about, they only care about their position. They don't care about where they are in relation to other stones. Otherwise, the value of other stones don't matter to compute their own value, which means that we actually don't need to be holding this in memory constantly or in this array. So what we can do is we can use a file as a temporary buffer for this, which is going to be a little more complicated. So first of all, we pull this in, that's fine. And what I want to do then is we'd actually want to be using, let's just do this. Let's let file num and function get next file num file. So I want to create a function that gives me buffer files, and we're going to return here path.join name buffer out, and I want that actual file num in there, ++, not new, and there we go, .txt, perfect. And so what this is going to do is this is basically going to, because this is a post increment operator, this doesn't come up a lot of the time when writing code, but it's important right now. This will give you the current value of the variable as the result and then increment it. If you want to do a pre-increment like this, it'll increment and then give you the value, but I'm not too worried about that. So what I want to do then is I actually want to open, rather than doing write file sync or read file sync, which pulls in the entire contents of the file, we want to actually open a handle. Let's actually do this. Buffer handle equals, and this is not going to be a read stream, it's going to be a write stream. Okay, get next buffer. Okay. And now we can just write whatever we want to here. So I'm actually going to go and loop over nums, and we're just going to write it in there. That is really not that helpful, honestly. I'm not sure. I wonder if the AI, there's some reason why we can't write more than... Oh, maybe they're chunking the file, actually. I think that's what they're doing there. Okay. So for now, we're just going to write these numbers in as individual lines. See, because there's actually a function we can call in here that read line, which reads all the way till the next new line. We could improve on that a little bit by doing like maybe 10 numbers between new line, but I'm not too worried about that. Let's do this. Okay, and now run this. Oh, let's run process. Let's run part 2. Let's pull this out because I think we're not going to need that. Okay. Oh, it didn't do anything. Right stream. Well, let's check that then. Okay. I might be using this completely wrong, by the way. Buffer file. Let's just make sure we get the right path, though. Because I've never actually used create write stream in this way. Okay. That is there, so that should have actually worked. Create write stream path options. Let's see. Omit a close event after it's been destroyed. Print the option. Path. Okay. If you specify no file descriptor means no open event will be emitted. Oh, that's why. Because this is actually a specific. I have to wait for it to be open before I write to it. That's why. So I need, let's see. Handle equals fs dot open sync. And then we're going to open this in write mode. And then we actually stream. We need to open a stream from that. Because otherwise it actually does, it is actually async for this. And then this is going to be the stream. And then I think we can actually close the handle there. Maybe end the stream like that. All right, let's see what that does. Oh, okay. Path argument just be type string and not instance buffer URL. Well, it did create something. That is in line 18. Oh, so it doesn't like this. Well, you know what? Maybe I'll just write to the handle. That might be fine. I don't know if I actually need a stream here. That write is not a function. Okay, maybe that's because I think this is actually, yeah, this is a number. That's why. That's why. This is what we need to do. All right. I don't normally use these functions for this, and then fs.close sync. That's what we need. Okay. Cool. There's our numbers. So basically, we're going to do this every single time. So what we want to do now, let's do like maybe just one run for now. We're going to go here, and we're going to open our current buffer file. Just make this a let so we can rewrite it later. And handle. And now we're going to open sync with buffer file, but we're going to open it in read mode. And then while line equals fs.read, is there a read line, read link? I feel like there's a way to do this. Node fs read line by line. No, there's a stable read line core module. Okay. Well, let's make use of that then. Oh, this is like an interface. Ooh. Line reader, create read line, create interface. There's an end to nodes. Okay, well, I'm going to look at the official documentation. Okay. Read stream, file stream line by line, create read stream. Well, this might be a better way to go about it, honestly. But this is using promises too, so that makes things interesting. All right. Well, let's just do that then, because that seems like a better way to go about it. Okay. I could also use that. This is actually like a newer nomenclature for making sure it's the core module, which is fine. I'm not actually going to worry about that one, and I'm not going to do this either. Okay, create interface. So then what we want to do is want to pull in stream equals create read stream. Okay, and then we are going to use our buffer file. And this needs to be promisified now because this is all Let's grab this. You can see this is all in await, which means that I need to run this readline stream. I need to run this as a promisified thing that can actually handle that. It's going to slow some things down, which is not the end of the world. I think the other thing too is I also could use the file stream read and just read in bytes until I get to a new line also, but this is fine. So what I'm going to do here is I'm actually going to wrap all of this, the whole thing, in a self-executing asynchronous function. And like that. So what that's going to do, what are you looking for? Yeah. Okay. And what that's going to do is give it the ability to have await promises in it. So that should be here. Yeah, that's that. Close it off and execute it. But something is off here, and I think it's probably because, oh yeah, I just added that in. That's why. Cool. There we go. So now we just parse that. And instead of new nums push like this, we instead want to actually also open a write stream. So kind of like how we're doing here. So now let's call, we've already used the buffer file there, equals get next buffer. So we're going to start, basically we're using a file now as our memory, and we're only going to hold one number at a time. This will actually take a lot longer, but will not take up nearly as much memory because nothing's being held there. Okay, so now we got to open that again. This is why I used lets on these. Okay, now we're opening that for write, which should create it. And now, at the end of this, we do want to close it. And we also want to close our stream, which should be stream.close, I think. Yeah. So in here, now I'm just going to say fs.write sync. This is going to be the buffer handle. And we're basically sending 1 in a new line. All right, so every time we push here, we're going to do a write sync instead. And this is going to be first num. I don't know if this is actually going to work, so it's going to be interesting to see. And second num, because we no longer should have new nums. In fact, I should probably get rid of that. It might even be gone anyway. And then here, we're just going to write this num times 24. All right, so let's just run through this with one tick. So we got that one, see what it does. Okay, stones at the end doesn't make any sense anymore. Actually, you know what? Let's just leave that there. We have to read back in the file. So here's our first one. Here's our second one, which I think seems reasonable. Let's run that over 25 and just see what we get. Okay, you can see it's creating a lot of these. And I want to actually pull in that console log here without the link, because that doesn't really help us that much, but just as an indicator. Okay, and that gives us what at the end? I think that works. Yeah, I think that works. And then at the end of this, we can actually use like a word count with lines to figure out how many are in here. And I'm going to change this to all done. Okay, so now let's delete these. Something we could actually do as well is we could remove these at the end to do cleanup, but I actually think it's kind of useful to have that debug, just so you can kind of see what happened. All right, let's try this with our input and just see if we get the same results. You see, it does actually take a little bit longer, and that's totally okay, because that's just how it's going to be. But the expectation is that even though it's taking longer, it should actually give us the correct answer without running out of memory. Okay, so what did this give us? 185,894. And what did we provide as our answer here? 185,894. Okay, so that's working up until this point anyway. Now, the thing about this too is we don't actually have to delete these. Because I'm using the opening with the right flag, it should clear all the contents of the file. But you know, let's just start this off now. Let's go with 75. 40 was taking a while, so I'm of the opinion this is going to take some time. Hopefully, after the inevitable hour that this takes to run, it's going to actually give me the correct result. I can't really think of a way to speed that up any. Something you might be able to do is you might, if you're working with a programming language that allows threads, you actually could create multiple threads for this. And something I could do if I were so inclined and really wanted to write a ton of complicated code for this is I actually could write something that would write to the file, okay, and then exit, and actually not just write to one file, but split the output across files, and then we could open up multiple processes that process each one chunk of the file and then have some complicated thing at the end to knit that back together. I think the amount of time it would take me to write that kind of code would actually be about the same amount of time that this will take to run. One benefit of this also is that because we are using a permanent file as our storage, if we ever crash on a specific step, so like let's say we get to step 40 again and it crashes, I can restart it from step 40 again. I just need to tell this thing that file num starts at 40, and then it'll actually just pick up from 40 again. I mean, I would have to change this as well. So maybe we actually do file num here, and that would fix that. Because all that data is permanently stored, we're not losing anything anymore. Though if it crashed on step 40, you actually want to start with the step before it because that step may not have finished. So anyway, let's kick this off again. Okay. So I'm just going to let this run and kind of chill, and we'll come back and see how we do. All right, so it's been about an hour, and we've gotten to almost the point that we were at before because everything is a lot slower. You can see here the amount of data that we're dealing with at this point is just staggering. So like I have a suspicion by the time it gets up to 75, it's probably going to be in like gigabytes of data, which, you know, if we're storing that all in memory is a lot. But at this rate of growth, like 5 ago we were at 100 megabytes. I don't actually have that much disk space on my computer, so I think I'm going to stop this process for now. I'm fairly convinced that given, you know, about 2 days of time and a much bigger hard drive, it probably would find the answer. But I think I'm just not going to finish the second part on this one. The code is here. As we've gone over, basically here we have a file number. If we don't give a file number, it starts from the input directly. Otherwise, it's just using a buffer file, which will be picked up automatically. In the loop, it picks up this buffer file, opens it as a read stream, and then opens the next buffer file as a write. Then creates a read interface, and for every line, basically runs the process and then writes it into that system. Couple things that we could do to improve upon the speed here. One is we could write multiple numbers to a line. And we could actually go quite hard with that because we know that the system can process a decent number of numbers. So we could even write like 100,000 numbers to a line. And the reason that that will speed things up is that every time you have to do a read line like this, it's going to take time because it has to fetch from the file. And fetching from the file is always going to take longer. So that would increase the speed quite a bit. It would make the code a little bit more complicated here. And then you could also buffer your writes and then just write one long string into the system. And that would also be fine. Another thing you could do to actually really, and this is more theoretical, but to really improve upon this is that with the number of lines that we're dealing with here, let's see, this would be WC buffer 41. What is this? This is going to be 149 million different numbers, and that's not counting all the numbers that have been processed already. We could do some analysis over this and come up with sequences. So it's very likely that if a number, we know if a number starts at 0, which some of these numbers do, for example, our input, I just have one that starts at 0. And this will get other numbers will be 0 at certain points. We know where those zeros go, so we could remember those sequences and not have to compute them again. And so at that point, we could just say, okay, well, this particular number is going to be sequence 53, and then we know where we can actually predict that out for the next like 5 or 6 things. The code for that would be significantly more complicated because we'd have to store a bunch more stuff. We'd have to have a lot more edge cases being handled, but I think it might run a little bit more quickly. So I leave that as an exercise for the reader to try that out and see how you get. But yeah, a little bummed that we didn't get to finish this whole one and get that second star, but I'm not about to spend 12 hours waiting for my poor little laptop to churn through all these numbers and figure it out. And I don't really want to spend the next hour and a half writing the more complicated code to make this work either. So if you guys do get it working, please let me know. I'd be fascinated to see what you come up with. Have a good one, folks. I'll see y'all next time.